Hello everyone and welcome back. So in our last lecture we learned what is Green's theorem and some application. Now in this particular topic we learn one more very important topic, which is Gauss Divergence Theorem. So Gauss Divergence Theorem is nothing but a relation between surface and volume integral. Surface integral means double integral, और जो volume integral है वो क्या है, triple integral है. So Gauss Divergence Theorem is a relation between double integral and triple integral. Okay, now let us see what is the statement. If capital F bar be continuously differentiable vector function. So continuously differentiable. Suppose capital F bar is F1 I cap, F2 j cap, and suppose F3 k cap. So F1, F2, F3, these are components of what? Capital F bar along x-axis, y-axis and z-axis. तो जो F1, F2 and F3 है, these are all continuous and their partial derivative exist. Then we say that this whole function is what? Continuously differentiable and vector function. In the region capital V bounded by closed curve C, okay, bounded by closed surface C. Now what is this closed surface? Suppose let us take x-axis, y-axis, suppose z-axis, okay, a surface, some surface is there. Suppose this is one surface. So this is a three-dimensional figure, okay. So since our screen is two-dimensional, so it looks like two-dimensional, but it is a three-dimensional. So inside this we have some region. That region, the volume of that particular region is V, and this particular surface is what? S. Not any point, if we draw one perpendicular along this direction, the normal is what? N bar. Okay, you see there is one N bar. So when you see the formula, what is the formula? Double integration over S capital F bar dot N bar ds is equals to what? Triple integration over V divergence of F bar dv. So this is the relation between surface and volume integral, and this is called what? Gauss Divergence Theorem. Okay, so in some book you'll see like this also, just one integral they will use, integration over S F bar dot N bar ds is equal to integration over V div F bar dv. The meaning is same. So if it is over V, so it means it's triple integral. If it is over S, that means it's double integration of surface integral. Now this capital N bar is what? A outward drawn normal perpendicular to this surface at any point. Suppose if we think about a ball, so a ball is what? Three-dimensional, like. So the region inside the ball is the volume, and the outer surface is the surface area what? S. Okay, just to imagine like this, and if we draw a perpendicular line on that particular ball, then we'll get a direction. On that particular direction, the outer normal is what? N bar. Okay, N bar. Or you can think like this also. Suppose there is a circle. So if we rotate that particular circle, it will become what? A ball, right? If we rotate 360 degree, a circle, if we rotate it 360 degree, then that particular circle would look like what? A ball, means three-dimensional. So that is how we convert it to surface integral to double integration to what? Triple integration. Okay, now how to find divergence of F bar? So we all know what is divergence. Divergence means what? This means our triple integration over V nabla bar dot F bar what? dv. So nabla bar means vector differential operator, which is I cap del del x plus j cap del del y plus what? K cap del del z. So if we find nabla bar dot F bar, so nabla bar dot F bar means what? I dot I is 1. So it will be del F1 by del x plus del F2 by del y plus del F3 by what? Del z. Okay, so this is how we'll find nabla dot F bar. So after putting here, so it will become like this: triple integration over V del F1 by del x plus del F1 by del y, and then del F3 by what? Del z. And now this dv will become dx, dy and dz. So what is the most important part? We have to put the limit of x, y and z. So in general, we'll start start putting the limit from z. First we'll put the limit of z, then y, and then what? X. That I'll discuss in the example. Okay, now let us go to the example. So this is our first example where we have to evaluate. See, here single integration is there, but it means since it is over s, so it means it's a double integration. So integration over s, f bar dot, here capital N cap is given. So the meaning is same. Capital N cap is what? Is the outward drawn normal on the surface at any point. So f bar is given here. Okay, the vector function is given here, and s is the surface bounding the region. Now this part is important. You see, one circle, you see x square plus y square is equals to what? 4. And there is a range z equal to 0 and z equal to 3. So between these two lines, if we rotate this particular circle 360 degree, so we'll get a 3-dimensional shape, and the volume of that 3-dimensional shape will be V, right? Okay, now let us go to the solution by Gauss Divergence Theorem. Gauss Divergence Theorem. We have so it's double integration, or you can write single integration also. F bar dot n cap ds is equals to integration over v dive f bar and then what? dv. So you can write like this: triple integration over v dive means what? Nabla bar dot f bar dv. Okay, so this is equals to, now f bar is given, right? Our f bar is 4x I cap minus 2y square j cap and then plus z square k cap. So what is nabla bar dot f bar? It will be del f1 by del x, right? So our f1 is how much? Our f1 is 4x. So we can write like this also, del 4x by del x plus del y of minus 2y square plus del z of what? f3. f3 is our z square. So what we will get? Del x of 4x, it is only 4, minus will be outside, 2y square. So if we differentiate it, you will get 4y, and differentiation of z square is how much? 2z. So this will come. So integration 4 minus 4y plus 2z and then dx dy dz. Now what is important? I said the limit. So here limit of z is directly given. So this is directly given. You see, z equal to 0 to 3. So no issue. Z equals to 0 to 3. But we have to find the limit of x and y. So how will find that particular limit? Let us see. Okay. So x square plus y square equals to 4. Now one more thing you remember, when you put the limit of z, then both x and y will be present. When we find the limit of y, we can put z equal to 0. And when we find the limit of x, we can put both y and z 0. So that's why I said that from z to backward direction we will find the limit. So here is very easy. The limit of z is directly given, is 0 to 3. So no need to think. Now when we find the limit of y, from this particular relation, y square equals to what? We can write 4 minus x square. Then y equals to how much? Plus minus, it is root over 4 minus x square. So when we put the limit, our limit of y will be minus 4 minus x square to plus 4 minus x square. So limit will be from negative to positive. Then we will find the limit of x. Okay, now if we find the limit of x. So what I said, this is the circle, x square plus y square equal to 4. So when we find the limit of z, nothing, we can put 0. When we find the limit of y, we can put z equal to 0. But here in this particular relation, there is no z. Okay, there is no z. So we'll do some problem maybe in the next lecture, where you see that both x, y and z will be there. Then I'll explain in a more detailed way how to find the limit. So here, since there is no z, so we cannot put z, so directly we have to find the limit of y. Now, when we find the limit of x, what I said, we can put y equal to 0. So if we put y equal to 0, our x square equals to 4. This implies x equals to how much? Plus minus 2. So limit of x is minus 2 to plus 2. Okay, so is it clear? So it's very very good if you do with me, then you'll understand better. Suppose if you simply listen, then sometimes you will not understand few lines. So it's better if you do with me. Now x equals to minus 2 to 2, y equals to minus 4 minus x square to root over 4 minus x square. Now first we have to integrate with respect to z. So first term is what? 4. So it will be 4z if we integrate, minus 4y with respect to z is z, then plus 2 into integration z is how much? Z square by 2. Between the limit, what is the limit of z? 0 to 3. So now we have dx and dy. Okay, dx and dy. So this is equals to integration minus 2 to 2. If we put the limit, what we will get? 4 minus x square, then 4 minus x square. So if we put 3 in place of z, see, this term will become 12 minus, again in place of z, if we put 3, it will become 12y, and here is z cancel. If we put 3, then we will get 9, and if you want to put the lower limit, everything will be 0, then dx, and then what? Dy. So finally what we have? 21 minus 12y. So now what to do? Now we have to integrate with respect to what? Y. So you see, 12 plus 9 is 21. So integration 21 with respect to y is 21y, then minus 12y. 12 is constant, integration y is how much? Y square by 2 between the limit. So here when you put the limit, we have to be a little bit careful because the limit is a little bit different, right? So it's not tough, but we have to put the limit cautiously. So here this cancel out, 6. Now let me put the limit, x equals to minus 2 to 2. So first where we'll put the limit? 21 into, we'll put in place of y, right? So what is the upper limit? It's root over 4 minus x square minus, now in place of y, okay, now in place of y, we have to put this lower limit. So I have put minus, then when you put the lower limit, it will become minus minus plus root over 4 minus x square. Is it all right? Just observe it very carefully. 21 is constant. In place of y, when you put the upper limit, so first you put the upper limit, then you give minus sign, and then when you put back the lower limit, again one more minus will come. So that's why minus minus it will become plus. Then minus 6 into, now it is y square, right? Y square. So in place of y, if you put root over 4 minus x square, so square will vanish, you will get 4 minus x square minus, when you put the lower limit, now this minus will not come because y square is there, no? So 4 minus x square. So if you want, you can omit this particular line because these two terms will cancel out. Since it is y square, so if you don't want to write, so it's up to you. Then dx. So what we have now? Two similar kind of term, na? Root over 4 minus x square, again root over 4 minus x square. So integration x equals to minus 2 to 2, 21, then 2 into root over 4 minus x square dx. So 42 is constant, so let me take it outside. Then root over 4 minus x square dx. So there is one formula now, root over a square minus x square. So that formula we have to use now. So it's a little bit big in the formula. So it's how much? X into root over 4 minus x square by 2 plus a square by 2 sine inverse x by a. So our a is 2 here, between the limit minus 2 to 2. So 42. Now see, when you put the limit, upper limit, no, 2 here, when you put the upper limit 2, so 4 minus 4, it will become 0. When you put the lower limit, same, minus 2 whole square, again it is become 4 minus 4, 0. So this part will vanish for both upper and lower limit. So we have only this particular part. So it's 2 square means 4 by 2 is 2. Now let us see. When you put the upper limit in place of x, so it's 2 by 2, 1, sin inverse 1. Sin inverse 1 is how much? Pi by 2 minus. Now let us put the lower limit. When you put the lower limit here in place of x, so when in place of x we put minus 2, it's minus 2 by 2, how much? Sin inverse of minus 1. Sin inverse of minus 1 is minus pi by 2. Okay. So minus pi by 2 is how much? 2 into pi. So finally we have 84 pi. So this is the answer. So I'll suggest you do the calculation by yourself. If you are not getting the answer, then you check it from the this video lecture. Okay, now let us take one more problem. Use Gauss Divergence Theorem to evaluate. So here double integration over S capital F bar dot n cap. Okay, where see capital F bar is given. Capital F bar is how much? 4xy I cap minus y square j cap plus yz k cap, and S is the surface of the cube bounded by, now here this problem is very easy. You see, limit of x is directly given 0 to 1, y is also 0 to 1, z is also 0 to 1. So no need to think about the limit. Okay, now solution by Gauss Divergence Theorem. Gauss Divergence Theorem. What we have, we can write double integration over S f bar dot n cap ds is equals to how much? Triple integration over v div f bar dv. Okay, so now we have to find this div f bar. F bar is how much? 4xy I cap minus y square j cap plus yz k cap, right? So what we have to find? Nebula bar dot f bar. So how much it is? Del del x of f1. Our f1 is 4xy plus del del y of f2. Our f2 is minus y square, and then del del z of yz. Okay, yz. Now this is equals to, when we differentiate it with respect to x, what will get? 4y. Then second one is minus twice y, and last one is plus y. So how much it is? 3y. This is very simple. Now limit of x, then limit of y and limit of z we have to put, and divergence f bar, what we get? 3y dx dy, and then what? dz. Limit of z is 0 to 1, limit of y is also 0 to 1, limit of x is also what? 0 to 1. So it's a very simple problem. You can take 3 outside. X equal to 0 to 1, y equals to 0 to 1, or we can 0 to, okay, one term is okay, so it's how much? Yeah, then 3 we have taken outside, no? So now we have to integrate with respect to z. So it's only 3 we have. So now if we integrate it, what will get? Y, and then what? Z. Yz between the limit 0 to 1 dx dy. Okay, dx dy. And then 3 is constant, integration x equal to 0 to 1. So after putting the limit, what will get? If you put the limit in place of z, so 1 and 0, so you have only y, dy, and then dx. So now we'll integrate this part. X equal to 0 to 1. So integration y is how much? Y square by 2 between the limit 0 to 1, and then dx. So how much you'll get after putting limit? 1/2 will come out. So outside we have 3. So it's 3 by 2, and then x equal to 0 to 1 dx. So 3 by 2, and then integration dx is x between the limit 0 to 1. After putting the limit, how much you'll get? 3 by 2. So from this particular line, no? From this particular line, you'll do like this also separately. X equal 3 you can take outside, 0 to 1 dx, y equal to 0 to 1 y dy, and then z equals to 0 to 1 dz. Individually you can do and same answer will get. Okay, maybe 1 or 2 line it will be short. So these are the two problem. So in our next lecture we will do some more sums on this particular topic, that is Gauss Divergence Theorem, with some more bigger surface, so that we can find the value of x, y, z in a more detailed way. Okay, so I hope you understand this particular lecture, and if you have any query then kindly write in the comment box, and if you understand my videos then kindly subscribe and share with your friends to get more updated lectures. Thank you once again for watching.